Thank you. So my name is Nikolay Piskun, and I'm total use software architect now at Perforce Software, and we're talking about total use debugger and techniques for debugging HPC applications. So I have a very ambitious agenda for today. Usually we spend 4 hours describing main features of total use, but I only have 35 minutes. So if I won't go through everything here, you still have my slides. So feel free to go and see some information that I will be talking about. So I'll talk about main features and mixed debugging, C++, and Python, also MPI, reverse debugging, in-memory debugging, and different HPC debugging techniques. So first of all, what is debugging and why do you need total use? So I think Ryan already talked and teach you how to actually what kind of bugs you have and how you need to debug them. So probably I'll spend a little less time and we'll talk about different features and debugging techniques and start with total use. So we are in production more than 25 years. First time was in late 90s. And right now, total use is comprehensive C, C++, and Fortran debugger. So what does it mean? It means that if you compile your program from C, C++ libraries and Fortran, you can mix and match them as you want, and total you will be able to debug it in one session. From the beginning, Totally was developed as multi-process, multi-threaded debugger, and as such, it has thread level individual control. So you can control and move one thread and keep all of them. All the rest hold. And you can also see thread-specific data and stacks, switch between different threads and processor easily, and view complex data types. As far as parallel applications, we support MPI, OpenMP, including advanced and hybrid and CUDA applications. So you can mix and match all of them together in one big application and debug in one session. We also have convenient remote debugging for remote debugging on HPC centers. And in addition, which is kind of unique for us, we have integrated reverse debugging and our developed memory debugging. We also do mixed Python, C++, and I have a nice video demo to show, as well as script debugging or offline debugging, so you can generate a script in batch environment and then see results after your program run. We support Linux, debugging on Linux, on Mac OS, and on basically any Unix, which is still in service. So let's summarize it here. So the total is not just a tool to find bugs. It allows you to understand complex code and improve code quality, collaborate with team members, and all that will allow you to shorten your development time. It's basically what you're shooting for. You want to find your bugs faster, and you want to collaborate, resolve issues, and go further and put your code to production as soon as possible. So what kind of bugs we usually looking for? You're looking for program crashes, data issues, and memory leaks, and communication problems. So I will be won't spend time on that and go directly to total default use. So total, I don't know how many of you debug for a long time, but this is different interface than maybe 5 years ago. So we are moving to a new interface, and right now I will be presenting a new one. So, but if you want to, for some reason, want a classic one, we still have it. It's available. You can switch on the fly to use old interface if you like it. Call it classic. It have a little more features, and their structures differently. So in default view, there is 6 main areas of debugger, and the first one on the left upper side is a process and thread control view. So this is your control area where you can easily switch between different threads and processes. In the middle, there is a source view. It's where all debugging happens. And on the right, up and down, there is linked call stack view and local variables view. So you can switch between different stacks if you stopped in nested deep function calls. You can switch and see local variables as well. And in the middle down, you can have data view, command line, input, output panes, and I will explain how you can work with them. Also, the last one on the lower part here is an action point, replay bookmarks. So it's where your action points and bookmarks stored. So let's go now to see a little more details. So process and thread view. So this is your, again, command and control view. It shows you the whole state of your multi-process or multi-threaded application. You can see it as a tree or list, and you can customize to have 3 different views. So you can select different attributes that you want to see, which is useful for you, and you can play with that, and I will show you the demo how to do that. But yeah, basically you can switch here between what thread you want to focus in your debugging. And when you switch, your source view will be focused on particular thread, and in a source view you can see highlighted sources. You can search the function here. You can add your data for data analysis, data view from this, and you can also set breakpoints in the lines. So you can see here there is bold lines. It's where you can set breakpoints immediately, and some lines you cannot set breakpoints. So it's all clear for you here. And you can also open for editing from the debugger. Call stack view and local variables view is basically also switching your application in different functions, and you can see local variables which are grouped as arguments and as blocks on particular line. And this is lexical blocks. So it's mostly related to C++, as you know, there is a lexical blocks of the scope when you see variables, and we also block it this way. In action point view, it's where you can see all your action points like breakpoints, watch points, and replay bookmarks. You can enable them all, or you can delete them all as you want. And a little overloaded area with different tabs is data view, where you can pull your data and you can modify them, you can change them, and you can see more details, transform to different structure. So this is your expression system. You can evaluate different expressions also in this view. And command line is command line interface to debugger backend. So you can run scripts here, and you can do a lot of advanced stuff to see different data. And if your program needs input-output, if you're debugging serial applications specifically, you can put here input and see what's the output as well. And there is also different logger, so you can see log information here as well. And let's now move to action points, which is one of the most important tools for you to view and actually modify the behavior of your application. So we support 4 different action points: breakpoints, evaluation point, watch point, and barriers. So let's start with breakpoints, which are the easiest ones. So each debugger usually have a breakpoint. So the breakpoint is what it does. It does what it says. So your program will stop. You can set it by single click on the line number or right click on any number of codes. So you have more information. You can put more attributes here. And you can also go to menu and set application. You can also use accelerator Control B. In this case, you can just type in the box the line number you want to set or the function. So you can also set breakpoints inside a library which is not loaded yet, and you can set a breakpoint inside GPU kernels before you actually load the kernel. And this is very useful if you don't want to stop and your application, each kernel start, I want to stop it only when you need it to start. And this will be called pending breakpoint. Evaluation points, sometimes also called conditional breakpoints. It's basically you can include instructions to be executed at a particular point. And in this way, you can test potential fixes or patch your program without need to recompile it. So you can test your patch and run it while you have allocation. Also, you can evaluate expression. And for example, in this case, if some variable is equal to 3, I want to stop. So you only stop when your variable looks fishy or you want at some particular points. There is also, you can put go to for C or Fortran, and that will skip the whole snippet of code. So you can skip any number of lines that you don't want to execute. That's why I'm saying this is allow you to control your application and change its behavior. You can execute totally function, any other function as well, and set different values. So examples will be as simple as just putting printf. So you can put printf in your program without need to recompile, and it will print out the value of interest. You can skip some code, like I said, go to particular line. For example, on line 60, you said go to line 63 without executing line 60, 61, and 62. You can also do a little more advanced stuff like stop a loop after a certain number of iterations. And in this case, each time I equal 100 or divided by 100, you will print the value of high or something else, and you can stop as well. And this $stop, it's a built-in statement. Dollar means that it's totally internal value, and you already paid for that. So watch points are different from breakpoints in a sense. They all set on particular specific memory location, unlike breakpoints that are set on particular lines. And execution is stop each time the value stored at that memory location changes. Another difference is breakpoint usually stop before the instruction executes and watch point after the instructions. You can easily set it from menu or from different context menu. The last one, barrier breakpoint, is more useful and it's probably only used for multi-process or multi-threaded applications. And it's used to synchronize a group of thread or processes defined in the action point. If you want to also change your program behavior, you want to see how it behaves. If you have a lot of synchronization, which may be not performance-wise optimal, but maybe more accurate, you want to see how program behaves with different executions, you set a breakpoints. And you can specify whether you want to, what behavior you want to do. You want to stop at the end, or you want to hold and then let everyone go. Or you want only the thread stops, not the processes. So there's options here and settings that you can do. And after you're done, you can save all breakpoints as safe as in a new file, or you can save it as default location, which is in the same location as your executable. So next time you start your session, all breakpoints from default location can be loaded, and you don't need to set it anytime more. Okay, so how you examine and edit data? As I said, the main window is local variables, and there is a lot of them, and they're usually specific to particular stack frame. You cannot modify them. So if you want to edit or save it in one location, you can add them to data view. And data view, you can edit from multiple locations. You can edit from source view, from local variables, or just drag and drop. And then they're inside one window, and you can investigate them. You can expand arrays, and you can also see all nested structure and dive in all. So let me show you an example of dive in all. This is nice animation. If you have an array of structures, which is pretty common in scientific calculations, sometimes you want to see only one value, for example, time or velocity, and you want to see it as a simple array. And totally allow you to first go deep and investigate it. So it's just going one more time. And then you can dive in all particular value X in this case, and this will transform it to simple array, one-dimensional with one structures, and you can see all of them in one array, and you can visualize and do statistics. Also, you can do a little more advanced stuff. You can set expression, you can do numerics or function calls, and I will show more examples on breakaway session. If you have an array in C, usually it's not a lot of information. You need to transform it to array, and total will allow you to do it by just simply typecast into another type. So from pointer, you can cast it to array and then expand it and just show it and deal it as simple array. Or you can change the type from integer to double to see how your data will look in this case. Sometimes it can be very useful, especially for C++ classes, if you want to typecast from one class to another. So I don't think I have time for demo, so I'll skip this time, and if I have time, I'll show you demo at the end. And go to mixed Python C++ code. So debugging one language is difficult enough, and understand how your flow of execution goes across language barriers is also hard. So what TotalU provides you is provide you easy Python debugging session setup and fully integrated Python C++ call stack, and all glue codes or wrapper codes between C and Python can be removed. You can also easily see variables in Python and C++ and use our reverse debugging and memory debugging the same way how you use it in simple application. What TotalU does not provide yet, we cannot set breakpoints and step in within Python code. And we are supporting mostly our user use case when you have a Python script which calls some libraries written in C++. It's basically most of the UI is doing this. So let me show you some demo in video for Python script, which is very simple. Basically, it's import libraries C++ and then call function fact and just send variable A. And it's doing it in multiple frames. So TotalU, you start TotalU and then you give arguments Python debug version, and Python will call Python script. So you're basically debugging Python debugs. So let's start. And so TotalU will start up, and first you will see, let's see, started, yes. So you don't see the source here because we don't need source for Python debug. You're not debugging interpreter, you're not debugging interpreter, you're debugging Python code and C++ code. So first, what you need to do, you need to set a breakpoint and in function fact that is called in C function. And this is pending breakpoint because library is not loaded yet. You hit go, and as a matter of fact, TotalU can debug scripts and go from one script to another until it actually find any application which can set breakpoint. So if you don't have a debugging support, you mostly see a lot of C function, which is glue code, and transform Python into some kind of C code wrappers. But if you click on call stack filtering, it transform and show you Python code as well as C code. You can switch between Python frame, which is here Python, and you can move to data view values which are passed between two different subroutines. In this case, it's variable A. And what is interesting, we didn't actually construct that you have different sizes of variables. In Python, it's 64-bit, and in C, I think it's 32. So you can see, you can easily switch between different frames in Python and see the source code, and you can also go and see your variables and line numbers in C++. As again, the only limitation, you cannot set breakpoint in Python code, but we probably will be working on this one next. And as you after you're done, you can save all your breakpoints in a session, and next time you don't need to set them again. You just save them and load. Okay, so let me stop here and move further, because I want to also talk about remote debugging. And this is what I will try to show demo if I have time as well. So we can do remote connections from your laptop or desktop. Currently, we support Mac OS and Linux UI clients, and we're working on Windows client. We always have remote display client separate application, which works on Windows, Mac, and Linux, but now we are integrated everything in one debugger. So also advantage is front-end GUI architecture doesn't need to match back-end target architecture. So you can have it on Mac and just connect to Linux. It's secure communication and conveniently set up. So how it works, you have a front-end and back-end, basically batch nodes, and debugger now can have two parts UI. First is on your remote system and on front node. And on front node, you start your applications and connect and debug from your remote system, from your laptop, basically. So it's very easy, straightforward. And in addition to that, we also have reverse connection, which is on the front node. You can put TV connect command in your request, and TV connect write request to shared space and total view on front node, and it can be total view client, which then connects to TV connect, and as soon as you get your allocation, your execution starts and stopped, and total view server connects, all of them connect to total view UI on the front end, and you can start with debugging. So this is how it works. Pretty straightforward, and you can put this command in your batch mode in front of srun on MPI run, and totally will just wait for connection. So I will show the demo of that. As soon as your connection allocation is ready, you click yes, and you can debug it on your desktop. Okay, so now let's move to another topic, which is memory debugging, memory leaks, heap status, and dangling pointers. So what is a memory bug? So let me just spend probably 30 seconds. I'm talking about heap memory problems, and the memory bug is mistake in the management of heap memory. So it can be leaking, failure to free memory, dangling references, failure to check for error condition, and memory corruptions. So totally support all of that detection. So we can detect memory leaks, dangling point references show you, and we can detect memory corruption writing out of bounds. In order to do that, we have our own technology, which is called totally heap interposition agent. So you don't need to do any instrumentation for your source or binary. You just compile totally with your program with -g, and program runs nearly full speed. You just intercept all calls to malloc and then do all the magic. So it's very low memory overhead, but again, you can use it in also 3 different levels: low, high, and expert. And if you want more memory power, then you will probably spend a little more time. But in general, it's very low memory overhead. So we have special debugger for that. If you're only interested in memory debugging, and you can run memory escape, and we have it for a long time. It support all features, including support for MPI. And now we are decided to integrate it in a new UI. So for upcoming release, which is in a couple of weeks, we support leak detection, heap status, and dangling pointers. And we are working on memory error events, corruptions, memory block painting, and memory comparison between processes. So everything which memory escape, and you can still use it now, will be transformed to new UI. And having memory escape, memory debugging, and source debugging in one place is very beneficial, because you can stop at any breakpoints and do your memory analysis. You can run your memory leak report at any point, not wait till the end. And you can also integrate a lot of nice features like heap status. Another unique feature of Total is reverse debugging, which we developed with our partners from Undo. And reverse debugging allow you to add one more dimension to your debugging. So when you can activate it before program start or later on, and you can move in your program, kind of move in both directions, forward and backwards, which actually makes sense going backwards. So you want to see the errors once it's happened. So if it's a crash, you cannot restart the program. Sometimes you need to go back and see what happens before. And reverse debugging is basically record all your program execution, even MPI with all calls, and allows you to effectively go back and forth many times. So it's kind of moving from one direction to two directions. So it's double your debugging capabilities. And after another very interesting feature, which is gaining a lot of attention now, is you can save your session and then you can debug it later. So for example, you have your location, you run your debugger, and you find your error, but you don't find the bug. So what would you do if your location will finish in 5 minutes? In this case, you save your debugging session, and then you can even move it back to your desktop or the machines that you developed, and then you can continue debugging off your center. So this is really powerful features. And so everything in forward debugging can have reverse control. So you can run forward, backwards, next forward, or step forward to next backwards. There's additional one, you can advance to live session and continue run your execution. And you can also create a bookmark, a point in recorded history. So next time you just click on bookmark and go back to the point of interest. So especially if you save your session, you can save bookmarks. So it's like you have a book and you can move many times in one debugging session. And okay, so I still have time, so I'm glad to talk about CUDA applications. So we can debug CUDA for a long time. We support all cards which are now on the market, and we support latest SDK. We can debug 64-bit, of course, CUDA programs, and supporting dynamic parallelism, support MPI, and also we can leverage CUDA memcheck. So what is also separate us from different debuggers, and what is also very useful if you debug in CUDA application, you can debug everything in one session, and you can set breakpoints which will be which can be unified for your CPU and GPU if you don't know, for example, whether your code will be executed on GPU or CPU. So in some cases, it depends on your system, which if you're talking about portable applications. And you can set the breakpoints before you load your CUDA, and then you can also switch between different. And if you said before, it's a nice example. It's a hollow breakpoint, so you can, because debugger doesn't know yet where is a line number because the image is not loaded, but you can set breakpoint and it will be moved to the closest line number where you actually launch your CUDA, and you can save them as well. For if you have CUDA, then you have two additional controls, logical and physical toolbars, where you can switch between blocks and threads or between devices, SM, warps, and lanes. And we are also working now on supporting not only CUDA but and NVIDIA, but also AMD. Specific for CUDA, we show different memory qualifiers like local or generic memory, and we show you all data that is in your CUDA application, and you can switch between different threads or warps and see different data as well. So let me show what is specific for Argonne. For Argonne, we have a labs, and also in common folders. There is some labs and total view. So if you want to use remote connection, it's very easy to use. You can download, install total view on Linux and Mac machine now, and it's just don't worry about licensing. If you only debug in remote, you don't need a license on your local machine right now, and I think it will stay this way. You connect to remote node and you put your remote host path. There can be more than one. And then, for example, for Kuli, you can put a path to totally executable, or you can just put a remote command. In this case, it's soft add plus total, so or module load total in different machines. So you can run your all labs remotely, or you can do it here.
Nikolay, we have 5 minutes now.
Okay, great. So for hand-on lab, I will show a different example in labs, and you can also install total installers, start total view, and we have 3 labs: debugger basics, we examine an array, and controlling parallel application. So totally available the same way like any other commands, and we also have resources. You can go and see more. We have webinars and videos and a lot of the video tutorials, everything in totalu.io website. And in a summary, use a modern debugger, save your time. And with totalu, you can do cross-platform, allow you to debug GPU in one session and debug your multiple languages. So I can do a demo, or I can have a question. I don't know how many questions are there.
Okay, great. Thanks for talk. So I think I see the 2 questions in the Zoom chat, and also 1 question in the Slack channel for the purpose. So yeah, you can ask those questions.
So can TV be used at runtime to find the source of memory leak in a long running program? Yes, so this is basically what we're using. We run our memory debugging at runtime, but we don't detect it immediately and report it immediately. So instead, you can stop at any point, and then you run memory leak report, and it will show you all your memory leaks at any point of execution. Or if your memory debugging is enabled, at the end, it will stop and ask you whether you want to run a memory report, and it will detect all your memory leaks. So this is from efficiency point, because we don't want to check each block each time during the program. It will be too slow. So our main objective, because we usually, our customers have long running programs, we want to run it as needed. Second question, what technique do you use to wrap malloc? Yes, we do LD preload. But also we have a static library which we can compile on Cray for static executions. So for static one, we supply your library that you will compile. Okay, let's see if I can find another question. So the question is, does it support OpenMP offloading? I don't know if this question is about GPU. I'm not sure, but I know we support for CPU. And actually, let me rephrase it. Yes, we do support it, but I cannot give you a lot of details. There may be some information missing on GPU. So I can follow up on that, but I know I did test it and see it on CPU side. On CPU, we do support it, and we can also show tasks. And if you have OMPD compiler enabled, which probably only Clan do that, we show you much more information from OMPD library. Any other questions?
Okay, great. Is there any other question to Nikolay?
Sorry?
Okay, so I don't see any other question. And